Welcome back. We had discussed about the green solvent for sustainable future. Why green solvent is a need for today and how the sustainability is important for our life. Sustainability improves our quality of life, protect our ecosystem and protect our natural resources for the future generation. And in previous lecture we had discussed about the different types of green solvents, properties of green solvents, why the green solvents are important for the chemical reactions and for environment and as well as how the conventional solvents are a great concern for our health, for the environmental degradation. And we had discussed about the different properties of green solvents. So we are discussing here the bio-based solvents, and as I told you in the previous lecture, the bio-based solvents are obtained from the agricultural crops, or we call this biomass. So here we are discussing bio-based ethanol, because the bio-based ethanol also called biofuel. So this biofuel is currently the most produced of all biosolvents, and industries are using biosolvents, and industries also preparing or synthesize on the large scale. And the world first cellulosic ethanol, that is biofuel, is synthesized or produced that from the plant which was commissioned in 2013 by Beta Renewables, and that biofuels are obtained from the agricultural waste such as rice, straw and giant sugarcane. And ethanol is most common uses are ethanol. We have to use ethanols as a biofuels, which is a very important topic of discussions nowadays. Researchers are doing a wonderful job, a lot of research on biofuels and how can the biofuels are obtained from other resources which are natural resources. So these are the biofuels. We have to use ethanol as a biofuels, and also used as a solvent in consumer product such as perfume, food coloring and alcoholic drinks, medicines and also some other products. So the large scale of production of that methanol, which is currently achieved using the fossil resources, and that is derived by the resources hydrogenation of carbon monoxide in presence of catalyst like zinc oxide, chromium trioxide and calcium zinc oxide with alumina. So on your screen you can see the biosolvent which is derived from the agriculture crops or agricultural waste. So learners, as I told you, when we produce that bioethanol, along with the bioethanol which is act as a biosolvent, we can obtain a very important biosolvent like glycerol. So the glycerol is a raw material which can obtained from the biosolvent by the hydrogenation reactions. So glycerol is produced byproduct of biodiesel, and production of 1 lakh liter of biodiesel, it generates 10,000 liter of glycerol. And glycerol is a very good solvent because it is having very low toxicity, and due to its sweet in taste, and due to sweet in taste, low toxicity, biodegradability, low cost, it is used directly as a sweetener in processed food, cosmetics and pharmaceuticals. So the glycerol has been used as a sustainable replacement for fossil derived solvent, especially monoethylene glycerol, and which is used in the purification of bioethanol. We get 199% of pure form of bioethanol. So glycerol, along with the glycerol, there are different types of byproduct we can obtain during the production of biofuels, that is bioethanol. Example, we can obtain Solvent, glycerol, formal, glycerol carbonate, glycerol oligomers, the polymers also, deep eutectic solvents, and also diols. So, these are the byproducts of biofuels or bioethanols. So, on your screen you can see that here the during the different processes, transesterification, esterification, carbonylation, so we get different types of solvents. So, Solvent, which is a byproduct of a glycerol obtained by the glycerol, is used as a solvent in paints, inks, fuel additives, or any other many more reactions. So, these are the very good green solvents which we can obtain from the biomass, from the agricultural waste. That is why we called it biosolvent, green biosolvents. So, Solvent, why this is Solvent is a polar in nature, and it is also act as a biosolvent, which is a bioproduct of we can obtain that Solvent from the glycerol. Glycerol is a byproduct of bioethanol. So, this Solvent is a polar and has a very high boiling point, that is 188 degrees Celsius, and it is having a good heat transfer fluid and used in gasoline and biodiesel, where it favorable reduce its viscosity. So, these are the some reaction we see here, the different types of biosolvents we can obtain from the biomass during the using the different types of reactions. Another types of solvents, biosolvents, which can be derived from the wood and agricultural waste. So, benzene, toluene and xylenes. So, benzene, toluene and xylenes can obtain by the conventional processes like petrochemical processes, but from oil refinery, but benzene, toluene and xylenes also can be derived from the wood and agricultural waste and used as a solvent in manufacturing. Especially benzene is used as a solvent in manufacturing of resins, rubber, lubricants, synthetic fibers, used in detergents, used in the different types of pesticides, also in drugs and plastics. And toluene and xylene solvent is used in printing, leather tanning, especially leather tanning processes, used in paint, nail polish remover, and as a thinner also. And another types of green solvent which we can obtain from the terpenes. So, the terpenes are a class of natural, having a class of natural solvents and obtained from the essential oils, because the terpenes are the plants which are having essential, which contains many essential oils, and that essential oil can be used as a solvent, as a green solvents. So, example, everybody knows the lemons and orange, that orange peel and lemon peels having oil, that is D-limonene. So, all the citrus fruit contain oil which is D-limonene, and that D-limonene industrially used as a solvent, degreasing, very wonderful, very good, having a very good property, used as a degreasing solvent and grease wool and cotton, and also used for the dissolution of cholesterol stones. So, all these are the solvent which we can obtain from the terpenes or citrus fruit. These are also called green solvents. The citrus fruit, that terpenes also contain alpha pine, that alpha pine which is used as a household cleaning solvent and also used as, that is a oil and used as a household cleaning solvent, and also used as a repellent insect and in the production of perfumes. So, all these are the bio based solvent, all these solvents are obtained from the plants. and that alpha pine also have very important medicinal properties as used as an anti-inflammatory antibiotic agent. So this is the structure of alpha pine, and here this is here is a plant based products. Similarly, acrylic esters. Acrylic esters also called lactates. So lactates are class of non-toxic and green solvents, and ethyl acetate is most common lactate esters having a very good solvent property. Here all these green solvents are environmental friendly solvent, they are biosolvent, excellent, that ethyl acetate having excellent cleaner property, and that used as a cleaner for polyurethane industry, can clean variety of metal surfaces, having can efficiently remove the greases, oils, can act as a adhesive and solid fuels. They are especially that biosolvent which can obtain from the bio mass are ethyl, we are talking about here ethyl lactate, that is, this is non-corrosive, easy to recycle and non-ozone depleting, having a non-ozone depleting properties, and this is non-carcinogenic in nature, and that's why this is very important, very good green solvent and used in variety of chemical reactions. We can use in many synthesis as a solvents. So the synthetic route to product which is ethyl lactate we can make, that is the carbohydrate, especially corn. So how that corn when the corn or which undergoes fermentation purification, after the fermentation purification the carbohydrate which is present in the corn, we get lactic acid. So that lactic acid during the esterification processes convert into lactate ester. So that's why this is called green solvents, because we are getting this solvent from the biomass. That lactate ester is used for polymerization of lactic polymer hydrogenases, propylene glycol, catalytic dehydration acrylic acid esters, and having a special derivatization properties, special product. So it is a green solvent used in paint and also as a growth regulators. Ethyl acetate has been replaced as a green solvent including toluene, acetone and xylene. So in place of that toluene, acetone and xylene, we can use that ethyl acetate as a green solvent, having excellent cleaner for polyurethane industry, can clean the variety of metal surfaces, efficiently removing greases, oil, adhesive and solid fuels. Another important green solvent is styrene. It is also called dihydrolevoglucosenone. It is a ketone. So this is styrene is a ketone and it is obtained from the cellulose feeds stocks such as bilberry press. It is also called bilberry press cake and also corn cob, poplar wood, and it is used as a solvent in many syntheses. All these biosolvents have unique physiochemical properties and used in pharmaceutical, cosmetics, chemical, energy, food and beverages industries. So making use of renewable resources in producing solvent is a promising and important strategy to move towards the sustainable chemical processing and to replace organic solvent derived from fossil raw materials. So these green solvents are recyclable, low cost, biodegradable and they are non-volatile, environment friendly, non-toxic, non-flammable, ozone depleting, greenhouse effect. So here when we use inorganic synthesis, we can use water, bio-based solvent, ionic liquid, supercritical liquid and fluorosolvent fluorous solvents are also green solvent, and these are the suitable for reactions which cannot be accomplished in supercritical carbon dioxide or supercritical water, and also with chlorinated solvents. So, these are the green solvents which can use in the organic synthesis. And ideal synthesis characteristics of using green solvents. So, learners, these are the very important characteristics. When we use these green solvent, any chemical reactions, what happen? During the reaction we get a 100% yield, atom efficient, no waste, we cannot obtain any type of waste. The reaction is only one step reaction is very safe. Renewable the green solvent which we are using during the reaction, it is a renewable material. It is also eco-friendly, having low cost. So, greener organic solvents used in the analytical chemistry. So, these are the different green solvent which I had discussed in the previous slide are used in analytical chemistry: bio-based solvents, water, supercritical liquids, fluorous liquids. So, application of these green solvents are petroleum industry, rare earth element recovery, used as a biocatalyst, pharmaceutical industry, fundamental and industrial application, and also processing of biopolymers. So, these solvents and catalysts are green solvent and green catalyst are the most important parameters to be considered for the greener strategies. A substance is considered to be toxic when we call any substance is the toxic if its oral LD50 value is less than 500, we call it is considered to be toxic. When dermal LD value 50 is more than 200 milligram per kg. Now, water as a greener solvent. Why? What are the characteristics of water and why we call water as a greener solvent? So, learner, because water in all biochemical reactions which takes place in the nature, that reaction used water. Example, digestion, which is a natural biochemical reaction, photosynthesis, this is also natural biochemical reactions, aerobic cellular respiration, anaerobic cellular respiration. So, all these are the biochemical reaction, and all these reaction used water as a greener solvents. So, water makes up 75% of human body weight, and why? Because all water is a polar in nature, and most of biochemical reactions use that water as a solvent, and most of the organic compounds or most of the compounds dissolve in the water. Another example where the chemical reaction takes place, that is rusting. Everyone know about the rusting, and during the rusting the water used as a solvent. So, rusting takes place in presence of water. So, water also participate in building larger molecules in cells. DNA and proteins are made up of repetitive units of smaller molecule, and putting these small molecules together occurs through a reaction that produce also water. So, water is a molecule which is polar in nature, and most of the substance dissolve in water in any other chemical polar molecules. So, it allows the chemical bond hydrogen bonding takes place. We can the reaction with the molecule or any compound dissolve in water, chemical bonding takes place, and due to that chemical bonding it easily water have a ability to dissolve the compound. So, compound easily dissolve into the water. So, water is called a universal greener solvents. So, water has gained immense popularity as a potential solvent for the synthesis, and all these syntheses where water used as a solvent are more environment friendly reactions. Advantage of the reaction where we use the water as a green solvent is a low viscosity, ease of solute movement, natural, because natural abundance of water in nature, so cost is not high, we can get easily water, high specific heat, the water having a high specific heat, so better temperature control takes place during the reaction, high surface tension, or we can say water having a wonderful wetting properties, and as I told you, because of abundance in nature, it is low in cost. And also water have high dielectric constant, that is also called solvation property, and during when we use water, the operation of reaction is very easy and safe, it is very safety concerned. Water is non flammable, it is a non toxic, and synthetic efficiency, or we can say potential for new synthetic methodology. So recently developed important reactions which carried out with water are pericyclic reaction, reactions of carbon ion equivalent, reactions of radicals, reactions of carbonium ion equivalent. So first one example you can see on our screen, preparation of biologically active quinoxylene and their derivatives. So quinoxylene and its derivatives have anti-cancer, antibacterial properties, and water is used as a universal solvent which display both economic and environmental advantages. So this is the reaction. This reaction can take place with tap water. So in presence of catalytic amount of cerium ammonium nitrate and along with the tap water used as a solvent here, as a green solvent here. So 1,2-diamine and 1,2-diketone when react with tap water in presence of a catalyst, we get a quinoxylene derivatives, and you will be surprised that the reaction, during the reaction, it's very easy reaction, one pot reaction, and we get a 80 to 98% yield. Learners, here water catalyze the condensation reactions. During that reaction, high yield of products we obtained. So no surfactant used during the reactions. Ease of separation is very easy. No organic solvent used during the reaction. So water is a safe green chemistry approach. So other green organic synthesis, that is, here we used also bioethanol. Ethanol, as I told you, is a biosolvent, and during that biosolvent we can obtain also quinoxylene derivatives. So this reaction takes place with the nanostructured pyrophosphate catalyst. So here ethanol is used as a, especially bioethanol is used as a green solvent, and we get 98% of the product. So if we talk about the effect of the solvent, so there you can see the different percentage of the solvent we get, but when we use water in this reaction, the quantity or percentage or yield of the quinoxylene is maximum. So on your screen you can see the volume of ethanol in the synthesis of quinoxylene. So this is the effect of solvent during the preparation of, during the synthesis of quinoxylenes. So another important reaction, that is the Claisen rearrangement reaction. This Claisen reaction takes place with water and the room temperature. So here we get 100% product, the yield is 100%. So this is also greener and cleaner synthesis. So there is no environmental impact takes place. The reaction takes place in a room temperature, very efficient, energy efficient reactions. And similarly, another important reaction, this is a industrial application where the synthesis of triazole. So the triazole reaction takes place with the green solvent. So these are the industrial processes, industrial synthesis where we can use the biosolvents or the green solvents. And if we talk about this reaction, if we use heptane, we just get the 46% of the product. Similarly, if we use the toluene, we get the 51% product, ethanol 40%, and in neat we get the 72%. But if we use the water as a solvent, we get the 98% of the product. Another important type of solvent is supercritical fluid. So supercritical fluids are also in the category of green solvents. Supercritical fluids have gained attention from research community from the 1980s, and they used as a green solvent in the synthesis, extraction processes, chromatography, or as a reaction medium in fluid depositions. A substance is called as a supercritical fluid when the temperature and pressure are higher in its critical values. Carbon dioxide used as a solvent as a key product from various industrial processes including fermentation, cement industries, and fertilizer sets. So here the critical liquid can exist as a liquid and gases at their critical temperature and their critical pressure. So this is the supercritical water you can see on screen. So just I wanted to tell you before concluding this lecture, supercritical carbon dioxide used as a green solvents in decaffeination of coffee and tea, defeating of cacao, production and extracts from hops, oils from sesame seeds, extraction of pesticides from the rice, extraction of antioxidants compound from vegetal materials, especially phenolic materials. And because this supercritical carbon dioxide have higher diffusivity, lower viscosity, and lower surface tension than conventional solvent. So these are the environmentally friendly solvent, minimum health environmental risk. So in this part we had discussed about different types of green solvents which we can use in industrial and chemical purposes. Thank you.